Alright, now we need to talk about a second type of energy. One that's kind of partner to potential energy, especially if, say, you release the potential energy. So kinetic energy occurs when an object is in motion. Alright, so if you remember, potential energy was related to the position and the object was not moving. So say you drop the book and now it starts moving. That's when kinetic energy starts taking over. So kinetic energy is dependent on mass and velocity in this relationship. Ke is equal to 1/2 times the mass times the velocity squared. Okay, so just like with PE, Ke is one variable. So that always stays together. You never separate those two letters. Okay? So let's talk about this in a little more detail. So first off, we need to confirm that the units are the same. So if Ke is measured in mass and velocity, you know the units for mass are kilograms. And then because it's velocity squared, the units for that portion is actually meters squared divided by seconds squared, right? Because you take the meters per second and you square them. Now, you can rewrite that slightly, pull the second meter out, and then you'll have a kilogram meter per second squared times a meter. Then if you remember those true-false questions, kilogram meter per second squared is also known as a newton, which means we technically have newtons times meters or joules. So yes, units are the same, joules or newton meters. You can write them either way. So a sample problem, just straightforward using the equation as written. If we write out what we know the mass. If a 5 kilogram object is moving at 20 meters per second, what is the object's energy? All right. Even if it doesn't say kinetic energy, since it's moving, that should indicate to you it's kinetic energy. But we know our mass is 5 kilograms, and we know our velocity is 20 meters per second. So we know our equation is Ke equals 1/2 mv squared. We can substitute in Ke equals 1/2 times 5 times 20 squared, which then would become 2.5 times 400, or 1,000, and then your units be joules, or if you really wanted to, newton meters. All right. Now, that's not the only way you can use this equation. You can also solve for mass, or you can solve for velocity. So let's rearrange these to do that exactly. So we have 1/2 times m times v squared, and we want to find mass. So our ultimate goal is to get the m by itself. So since it's multiplied by 1/2, all right, you can divide by 1/2 or multiply by the inverse. Essentially what we want to happen is that to turn into a 1. So if you ever have something that's being multiplied by 1/2 and you need to move the 1/2 to the other side, multiply by 2. Because 2 times 0.5 is 1, and 1 times any number leaves that number the same. So our first step is multiplying by 2. So you're going to have 2 Ke equals mv squared. Now from here, hopefully it's kind of familiar with what you do. We want m by itself, so we divide by the v squared. So m is equal to 2 Ke over v squared. All right. Rearranging for velocity starts out very similarly. We move the 1/2, so we multiply by 2. So you have 2 Ke equals mv squared. And then we can get v squared by itself by moving m. All right, and we'll have v squared is equal to 2 Ke over m. But we don't want to know velocity squared, we just want to know velocity. So how do you undo a square? Hopefully you're saying square root. So if we square root both sides, we'll have v is equal to the square root of 2 Ke over m. When plugging this into the calculator, make sure you figure out what 2 times Ke is, divide by m, and then finally square root. All right, if you plug it in straight as is, depending on your calculator, it may just take the square root of 2, and then multiply by KE, and then divide by M, and then you're not taking the square root of everything. So always do the square root last, okay? So let's apply this to some samples. So if the kinetic energy of an object is 1,125 joules and it's moving at 3 meters per second, what is the mass of the object? So we're going to have our KE equals 1125, and our V is 3 meters per second. And our equation starts out from the KE equals 1/2 mv squared, but then we want to find mass, so that's equal to 2 KE over velocity squared. So if you substitute, you're going to have m equals 2 times 1125 over 3 squared, which becomes 2250 divided by 9, which if you divide that out becomes 250. That says 250, and our units will be kilograms. Okay? Let's find a velocity. So we have a 360 kilogram object with a kinetic energy of 2,880 joules, and we want to know the velocity of the object. So what we know is the mass is 360 kilograms. We know KE is equal to 2,880. Those do not look like 8s. Joules. And then our equation is going to come from KE equals 1/2 mv squared, which to solve for V is the square root of 2 KE divided by M. So V is equal to 2 times 2,880 over 360, which will become V equals the square root of 5,760 divided by 360, which then simplifies again to the square root of 16, which is a perfect square, so hopefully you can say your final answer is 4, and your units are meters per second. All right, so that's how you can utilize this equation. Just keep in mind the key difference between those two types of energy is potential is based on position, how high off the ground you are. Kinetic is based on your movement or what your velocity is, and both involve mass. Okay? So make sure you have notes in class and fill out the online form, and I will see you in class.